I know it's the end of the day, and we've all had a lot of content to digest, so I'm actually going to keep my talk pretty short, hopefully. In fact, I'm going to try to do something a little bit differently than I'd originally planned. When I originally proposed this topic to Bart, I imagined a full hour of being able to kind of talk through the problems that DBAs face with running databases in Kubernetes, maybe proposing some solutions. But I want to turn this more into a dialogue. Since I'm limited on time, I'm actually going to kind of propose the problems and kind of itemize them. It's not going to be anything you haven't heard before. Probably throughout the day we've been talking about these same problems. And then just kind of turn it more into a discussion, like I said, and we can solve these problems together. There's going to be a call to action at the end. Let's talk about how we can solve some of these problems together. I'm going to leave plenty of time for a Q&A, and then whatever we don't answer here, let's take it into the Slack channel and keep that conversation going. So, quick introduction about myself. My name is Umair Mufti. I am a product manager at Portworx by Pure Storage. In fact, specifically, I am the product manager of a brand new product that we just introduced 2 weeks ago called Portworx Data Services. And if you haven't read the announcement, or if you haven't seen the announcement, I highly encourage you to head over to the Portworx site. We've posted a bunch of blogs and light boards and demo videos. You can register for early access to PDS. The TLDR for Portworx Data Services is that it allows anyone to create a database as a service on top of Kubernetes. That can be on-prem or in the cloud. It can be multi-cloud, hybrid cloud. So it's very apropos to what our DOK day is here today. If that wasn't shameless enough, I'm going to actually do another shameless plug. We're hiring very actively for the team. Feel free to find me on Slack, DOK community. You can tweet at me, you can DM me. My email address is up here. As I go through today's presentation, if you see some of the problems that I mentioned and you say, hey, I've solved that before, or Umair, I disagree with the way that you're approaching this, it's all valid. You should come at me with those, and we're happy to find a spot for you on our team to solve some of these problems. Getting back to the matter at hand, previous to my work at Portworx, I was actually at DreamWorks for almost 8 years. I started life there as a DBA, as a Cassandra DBA to be specific. By the time I left, I was managing the data services team, where we actually built a database as a service platform on top of Kubernetes, and we were running over 10 different database types on Kubernetes by the time I left. If you didn't get a chance to listen to Ara's discussion earlier today with Sylvain, I highly recommend you go back and listen to it. He does a great job of talking through some of the challenges and the journey that they went on to get all the databases onto Kubernetes. I'm not going to rehash it here, but I will suffice it to say that a lot of my lessons learned during that time at DreamWorks are actually informing this presentation, this discussion today. So kind of cut my teeth there at DreamWorks. So let's talk about the problems, right? What is it that's so hard about running databases on Kubernetes? We've probably been saying 100 times today, and we've been hearing it, that Kubernetes wasn't built for stateful applications. It was built for stateless applications. But what does that really mean? And haven't we solved some of these problems already, right? Probably the biggest misconception I hear with with the industry, or even people that aren't DBAs, to be honest, is that stateful sets exist, right? Doesn't that solve all the problems of running stateful applications or databases on Kubernetes? And the short answer is no. It's much more complicated. And as an aside, when I was at DreamWorks, we actually were first of all, we were very early adopters of containerization. We actually were building databases in containers before Docker. So we were doing LXC, we went to Docker. In the very early days of Kubernetes, we evaluated to see if it would be a solution. And that was before stateful sets existed, right? So it was a non-starter, it was a showstopper for us. And while it's true that when stateful sets were released, it did change the game for us. And it was actually the Portworx guys that had approached us at DreamWorks at the time and said, you guys should take a look at this again. So it's true to say that, yeah, stateful sets have enabled stateful applications, but it's not enough. And and this is going to be kind of a common refrain throughout my talk today. And if there's one takeaway from this, I'm afraid all the viewers are going to drop off after I say this. This is the one thing you need to learn from this presentation. It's that the hard part about running databases in Kubernetes is not that they're stateful. The hard part is that for most databases are distributed applications. And as we all know, distributed applications or distributed systems are some of the hardest problems in computer science. Probably naming variables and then distributed systems are probably like the top two issues. And that only gets more difficult when we try to manage these things with an orchestrator like Kubernetes, right? It's not just that I need to have a dedicated Elasticsearch master and dedicated data nodes. It's that Kubernetes itself needs to schedule those things and also be aware. So stateful sets don't really get us where we need to go. Which brings us to CRDs, right? So besides stateful sets, we have this notion in Kubernetes of being able to extend the Kubernetes API with custom resources, which is great. And before the operator pattern emerged, people often looked at CRDs as sort of the panacea for stateful services. And the problem, again, is that it really only gets us about halfway there. With CRDs, it's great that I can extend the Kubernetes API and have a notion of being able to define a custom resource that I can save in etcd in the back end. But really at the end of the day, if I'm not doing anything with that custom resource, if I can't apply any business logic to it, then it's somewhat useless, right? Which brings us to operators, something that we all love dearly, and there's been a lot of talk today about operators, and it's true, they are a game changer. Operators really have enabled sort of, I'll call it this next phase of stateful services on Kubernetes. But the thing about operators is, at its core, really, what the operator pattern is it's a design pattern, right? It's nothing more than a CRD and a controller. And so when I think of operators, I really think of things like the MVC framework, Model View Controller, right? And MVC framework is great for writing applications, but at the end of the day, you still have to write your applications. You still have to come up with the logic and build all the code and solve those solutions. It's just providing you the framework. And operator pattern is no different, right? We still, as coders, developers, we still need to develop the operators and define what those CRDs are. We have to define what the controllers are doing. And the result of that is that we're seeing a flood of operators being released into the market, and that's a good thing, but it's also problematic in its own way, because as we saw in the survey results earlier today, one of the problem now shifts to, well, which operator should I use? Which one? There's multiple Postgres operators. There's multiple Cassandra operators even. Which is the right one to use? What's the level of maturity? More so, if I'm running 10 different database applications in my Kubernetes cluster, which, let's face it, people are, with the advent of microservices and cloud native development, there's this notion of polyglot persistence, right? Microservice A might need a relational database, but microservice B is using a graph database, and C is using a key value store. So every one of these things has its own needs. So we're seeing many, many more database types needing support in Kubernetes. So if I'm now a DBA administering 10 different database applications in my cluster, I need at least 10 different Kubernetes operators. Not only that, but me and my team need to learn the syntax and the semantics and what are the custom resources for each one of these custom resources. So my hypothesis here is that what we really need beyond operators is actually a higher level of abstraction, something that's beyond an operator, something that sort of encapsulates specifically what databases need. And for all their talk of being different and graph databases doing something differently than a relational database, at their core, there are certain APIs or certain things that we expect of any data store, right? We expect to be able to scale it. We expect to be able to take backups, to monitor it, and a number of things. So what I'm going to be calling out to the community at the end of this presentation is really a call to action. Let's start discussing as a community how can we come up with some of those common standards that we can go to the database vendors and say, hey, instead of coding for this common operator pattern, why don't you code for a different level abstraction? And then we can just have one operator that rules them all, and your code will automatically work in Kubernetes, which is really, at the end of the day, what database vendors want. So before I get into solutions, I want to take a deeper dive into some of the problems, and we're going to come at it from a different angle here, which is to say, let's look at the specific resources that do exist in Kubernetes, and let's see who they were designed for, and let's see who they weren't designed for, right? You know, we all know the crux of the issue really, again, is that Kubernetes wasn't really designed with stateful applications in mind. And we see that reflected in the actual Kubernetes APIs themselves, the actual resources. And really what it comes down to is that DBAs have different needs than application developers. And that's really what we're talking about. So our first example is load balancing, right? So this is provided by the native service resource type, one of the oldest resources in Kubernetes. So if you're a application developer and you've developed a web app and you've got 5 Nginx pods up and running, it makes a lot of sense for you to just throw a load balancer in front of it, have your label selector point to each of your 5 Nginx pods, and any one of those pods can serve your read requests, right? But databases aren't necessarily that way, right? They behave differently. A lot of databases we talk about are sharded, and it might be that node 2 in my Cassandra cluster might contain the key that I care about. And so if I send a read request to node 1, and I'm looking for the data that's on node 2, well, either node 1 needs to redirect me to node 2, or node 1 just might not know about it and just kind of fall over. So the notion of just being able to balance the read request against all of my backing pods doesn't really make a lot of sense for a stateful application or a distributed application. Likewise, Ingress. How many of us use an Ingress controller in front of a database? We don't. It doesn't make sense, right? Any notions of the specification in the Ingress controller are talking about HTTP paths, host names, paths. These are all L7 HTTP constructs, but as DBAs, we really are thinking about other protocols, right? We're thinking about SQL, CQL, Thrift. Sure, there are some things like Elasticsearch and Couchbase that have RESTful endpoints, but by and large, what we need to be thinking about are different protocols. So what we really need is sort of a database-aware Ingress API, and I'll get to that in my next slide around solutions. Coming back to stateful sets, I talked a lot in the last slide about how they aren't the full solution. So let's look at what stateful sets do include support for. So there's a notion of, in the stateful set spec itself, there's a notion of a pod template. In my pod template, I can say I want to run Nginx, this is the image name, and I want to run 5 replicas of it. And again, that's great if you're running a web application where any of the pods need to run the same image. But in distributed applications and databases specifically, a lot of times we have a notion of topology, or that is to say some of the pods might have a different role or a different identity than the other pods, right? And again, Elasticsearch, you might have a dedicated master and dedicated data nodes. In Couchbase, you might have some pods that are servicing the data service and some that are responding to the indexing service. And so it might be that I need a stateful set that actually allows me to specify different images for different pods. I still want to think of the entire thing as one sort of atomic unit. I want to think of it as an application, a Cassandra application, or in this case, a Couchbase application. But I want to have different images or different pod templates for each of the roles. And that carries over to environment variables as well, right? So again, in the pod template of your stateful set, you can specify config maps or different environments that get attached into your pods, or setting the environment in your pods, and that makes sense again for a microservice. But like, again, common refrain, in a distributed application, this doesn't make a lot of sense always. If I have different roles, my pods each have a different role, they might require different configuration as well. Right now, there are ways around this, right? You might have an intelligent entry point script in your pod that's going to go and parse out the environment variables that you need and only apply them if, some condition is met. But you're necessarily making your image more bloated. And in any case, why should we do that, right? Kubernetes actually should have the tools built in to provide us those primitives to do that instead of us having to code that logic in at the image level. Finally, again, stateful sets, this notion of ordered scaling. If I scale up my stateful set, pod 0 is guaranteed to start first, and then 1, and then 2, and if I scale it down, the reverse order is true. By and large, that's a good thing, and it makes a lot of sense for non-distributed applications. But in the world of databases and database administration and distributed applications, we oftentimes want to shoot a node in the head, right? It could be that Cassandra node 1 has some file corruption or data corruption, and I need to decommission that node and pull it out and let the application replicate the data back across the remaining nodes. So I should be able to just scale out node 1 and let node 0 and node 1 remain. So these are just a handful of examples of the types of solutions that make a lot of sense for microservices and app developers, but don't make a lot of sense or don't translate very well over to the world of data services or databases. So what is it that we need? How can we solve some of these problems? So the first thing I'd like to point out is in whatever solutions we come up with, we need to redefine this notion of high availability. We always think about high availability in terms of making sure that my pods, one of my many pods is up and running. We think of service availability, right? But for a data service or a database, we need to flip that on its head. We need to be thinking about data availability. We need to be thinking about, again, I'm going to keep using Cassandra as an example. In my Cassandra example, if one of my Cassandra nodes goes down, do I still have a copy of the data somewhere? Can my cluster still respond and fulfill my read requests or my write requests? And it's a different notion of availability than what's built into sort of the common or the existing Kubernetes APIs, right? And this is actually much more complicated than it sounds. We have things like application level replication that happens. So again, Cassandra, my application might be having a replication factor of 3, or if it's Elasticsearch, my index might have a certain replication factor. And that might inform what I need to do at my stateful set level, right? It might inform the fact that, Cassandra's already replicating this data 3 times. Maybe I don't need a 3-node Cassandra cluster, or maybe I do. Or maybe it informs at the volume level if I'm replicating the block storage level too. There's also a notion of convergence, right? So my pod should be scheduled on top of my data so that there's low latency, but at the same time, we want that anti-affinity so that no 2 pods in my stateful set are scheduled on the same node, because again, if that Kubernetes node crashes, I need to be thinking of my data availability. So that's an area where I think we need a common industry-wide solution. Topologies. I mentioned this, or I kind of hinted at it in my last slide about stateful sets not having a notion of dedicated Elasticsearch masters or couch-based nodes. And really, we need an extension to Kubernetes that everybody agrees to, that's a common standard across all application types, that has this notion of topologies. Most databases, many databases, have this construct. And each one of the operators that I've seen is solving this problem in a different way. And so we need to standardize on that. Again, what I'm talking about is I need to be able to deploy a single, I'll call it a stateful set, but a single application where some of the nodes are running a specific image with specific configurations, and other nodes are running a different image with different configurations. Service discovery is also a pain point and one that needs to be solved. We often think of service discovery in terms of our clients being able to connect into, discover the pods or the services and be able to route their read or write requests to them. And while that's true for distributed applications, there's another notion of service discovery, and this relates to pods being able to find themselves, right? In a distributed application, node 3 needs to be able to find nodes 1 and 2. And again, there's some nuance here, right? So when node 3 crashes and Kubernetes reschedules it on a different server with a new IP, how do nodes 1 and 2 understand that this new thing that is joining the cluster is really, in fact, the same node? It's still the same node ID, it's still the same pod, even though its IP may have changed. And so this notion of cluster membership is actually quite difficult to do in a system like Kubernetes that's trying to handle some of these same semantics for you or these same constructs for you with trying to reschedule things. It could be that I need to actually scale to 5 nodes, and those 2 nodes that are joining are actually new nodes. Likewise, failure detection, the opposite direction, where if node 3 crashed or node 2 crashed, the other 2 nodes need to be aware of that node leaving. And any automated monitoring that you might have to set up for your cluster also needs to be aware that that thing that just stopped running, that pod that just stopped running, either failed and can't come back up, or it was just ephemeral and Kubernetes is going to restart it. Sure, its IP address might change, but it's coming back in, and it actually didn't fail. It's just restarting. So, so that's service discovery. And then finally, Ingress. I touched upon this again in the previous slide around Ingress API, Ingress controllers being very specific to HTTP requests today. And what I believe we need in the industry is a notion of data-aware Ingress. And this probably means a whole new Ingress controller API, ones that are specific, probably even down to database types. You can think of like PG Pool or PG Bouncer for Postgres, where it does load balancing, connection pooling. It knows that if my SQL insert statement is coming in, that it gets routed to my primary. If it's a read request, it can go to any of the secondaries. So I'm talking about read requests and write requests that are intelligent enough to be routed to the proper backing node on a request by request basis. And that, frankly, that doesn't exist today. So I think these are some of the higher level problems that we need to solve together as a community. And so that's where I'm going to leave it, really. I'm not going to propose any solutions here. Certainly, these are the types of problems that we're thinking about at Portworx, specifically in Portworx Data Services team. It's the kinds of problems that R and others had to tackle at DreamWorks. So there's sort of a lot of collective knowledge in this space, and we've been thinking about these problems for a long time. I know a lot of you have been as well, and certainly just the breadth and expertise of the presenters on in DOK Day today has kind of been testament to that. So what I'm asking for is let's get together, let's work as a community, let's partner together, let's create some standards that we can go to database vendors and say, hey, data stacks, don't code for this common operator pattern anymore. Code for this higher level abstraction, and by doing that, you'll automatically get all these benefits of Ingress and load balancing and all the other greatness that like a true distributed application, a true stateful distributed application in Kubernetes can benefit from. And I think that's how we solve some of these problems. So with that, I'm actually going to just open up Q&A, and then, like I said, we'll start the discussion here. I'd love to hear your thoughts, feedback, and whatever we don't answer today, again, we'll pull it into the Slack channel and keep that discussion going forward. So thank you.
I've got a question.
Please.
I've got a question. Because it's interesting looking at how we've gone from the last Kubecon that we did in May, being in this one several months later. And the Kubecon that we did in May, a mutual friend that we have in common, is Patrick McFadden, who gave a talk about, from DBA to SRE. So with this whole notion, really centering on the DBA, the role, and we talked about this as well previously in some of the panels, is like, okay, we have shifting technologies, but also sort of shifting responsibilities. And with having this background, what do you think are some of the barriers and how they can be overcome when it comes to this, like I said, sort of the mentality challenge, the cultural challenges that come along with starting to run stateful workloads on Kubernetes?
It's a very loaded question. The quick answer is that when I think of DBAs and I think of Kubernetes, I think of a Venn diagram. Mm-hmm. And I think of DBAs being one circle in my Venn diagram and SREs being the other circle. Mm-hmm. And the overlap is very minimal at best. Frankly, people who understand database administration might not understand how to build a Kubernetes operator. In fact, most won't, vice versa as well, right? So somebody who's skilled in writing a Kubernetes operator, thinking about Go code and thinking about mutexes, probably doesn't know much about Cassandra replication. And so in practice, I think finding that sort of that unicorn has been difficult. Certainly it was, certainly was for us at DreamWorks. And sorry to plug, but that's kind of the problem that PDS is attempting to solve.
And you're hiring.
And we are hiring.
And you're hiring.
And we are hiring. So we're trying to go after that problem. We think that it's a non-trivial problem. And as much as I'd love to think that, and I heard some of the talks earlier today talking about, we've crossed the chasm, and I get some of the sentiment, and I understand that for sure Kubernetes is ready for stateful workloads. But the administrators or the people that are maintaining these systems, there really is a dedicated Kubernetes admin, a dedicated platform engineer, and the database admin is really still a separate role.
Yeah. With that in mind too, because this is a recurring conversation that we've had in our community, based on that, one part is the empathy side, as you were mentioning. I think that's a very strong part that we can never forget the human element that needs to be incorporated in all these teams when we're talking about the stakeholders that are actively going to be working on, crossing this chasm. From a technical perspective, however, something that we've talked about on various occasions with some other companies is the, how do you codify these skill sets? And for other aspects of Kubernetes, they have CKA, CKD. A recurring question that we ask a fair amount of our guests is, how could you really structure the knowledge that's necessary in such a way? Once again, conveniently, this friend we have in common, Patrick, is writing a book, but more so on the side of certification, so that for organizations such as yourselves, as where you're working, is that when you're looking for folks to say, okay, how can you show me that you really understand this? What kind of stuff are you going to be looking for in the folks that you're going to be hiring? Great
question. Mentioning the book, again, another plug. Portworx is actually the sponsor of that book.
Fun fact.
So we actually are distributing some of the early chapters that Patrick and he's already released.
Yep.
And so I don't mean that to plug Portworx, but what I mean to say is that this is an area that we're putting all of the efforts and resources, not just at Portworx, but Pure Storage behind, and we think these are really worthwhile problems to solve. What we think we really need to find, again, are a lot of those unicorns, the people that do understand cloud native development, Kubernetes development, but then also things like very specific domain expertise in Cassandra, in Couchbase, in Elasticsearch, and those are the people that we're looking for.
And that's precisely one of the tricky things that folks have mentioned when we've talked about certification, because it's like, you have to do it database by database. You can't have this umbrella overarch because of the intricacies, the ins and outs of each kind of database.
I think what you'll see, sorry to cut you off, but
no, it's all good.
You have a notion of like a certified Cassandra admin, right? And I think what you'll see is at that level, sort of a certification for a Cassandra on Kubernetes.
Yeah, like a bonus add-on. It's like, that makes sense.
I know how to run this, but I also know how to run this in Kubernetes.
Mm-hmm, mm-hmm. I think that's a good point.
Yeah.
Taking a question from the audience, mentioned the asked in Slack too, but posting here for more visibility. I really enjoyed availability means data availability, not service availability. Any thoughts on SLOs and SLIs for that type of mindset? Particularly as we're talking about DBA to SRE, right? If we're thinking about SLOs, SLIs.
Yeah. Great question. Yes, I mean, I think those are all problems worth solving. I kind of hinted on it when I talked about needing to think about both convergence and anti-affinity. I think those lead into your SLOs as an organization. Certainly that is an important topic. I don't have any answers around it, but I do think that it's an important topic to. It's an important consideration when designing any sort of solution.
Yeah. And I think also, once again, when we talk about DBA, SRE, DBRE, database reliability.
Yeah.
And so
Yeah.
once again, that mindset of, okay, SLOs, SLAs, and SLIs also need to become part of my vocabulary. We're talking about ownership. We're talking once again about the stakeholders who's involved here.
Yeah.
And also customer-facing service. That we had a great conversation with someone from Google that's on their CRE team and saying, yeah, you're an engineer, but what you're really thinking about is, your customer's happiness and
Right.
what kind of metrics are really going to provide that, what kind of transparency from the get-go. These are not, they are technical questions, but they once again have a very strong, we can say business component, service component, customer-centric component.
Agreed. And bringing back to the customer, I'll point out when I was at DreamWorks, and again, the way we're approaching PDS is that we thought of our application developers as our customers, right? Mm-hmm. So we were building a platform where an application developer could come in and run any database on demand, right? Whether it's Cassandra or Elasticsearch or whatever. And so it was then on the DBA team to keep that thing up and running and think about providing an SLO or SLA to the application developer. So it was very much top of mind for us, providing availability, and that's why we would come up with best practices around how many nodes our stateful set would need to be for Cassandra, where it is that where we provide replication at the volume level, at the application level, even at the block storage level, and making sure that data was always available, or the database itself was always available to our application developers.
Mm-hmm. Very good. We're just about to wrap up, but I think it's going back to your comment on the previous question, is that talking about crossing the chasm. We're very much celebrating this. Perhaps it is happening, but then once again, our job as a community is let's get some visibility on that. Let's shed some light on that. Let's find folks and we did this today. We had folks in Singapore, in Australia, in different parts of Europe. Obviously, plenty of folks joining us today from the US, you here in person. So it's really refreshing to hear so many different voices about these experiences, seeing the different technologies that are going on. And it's great to see that your organization, your company's invested well into this, is saying this is what's going to be happening. We're in it right now, kind of vanguard situation, but we are. And once again, the survey, the research report really showed this and really brought it to light that this isn't just a crazy idea. We actually see this happening. So between
can I interject?
Yes,
So
I want you to interject.
I want to call you out specifically for building this community. I mean, the growth in DOK from a year ago to now is unbelievable. So props. And again, plugging Portworx, we saw that and we signed on as a platinum sponsor. So we again are putting all of the weight of our organization behind this community. And like you said, I mean, I think evangelizing that and solving some of these higher level problems so that the next generation benefits from our lessons learned, I think is paying it forward.
I think it's great, and that we see this momentum growing from KubeCon to KubeCon. When we did it in May, it was kind of like our first step out. Now really consolidating and focusing on, when we say data on Kubernetes, what do we really mean? Getting strict with that in terms of our content. And you'll see that in the following live streams that we have planned, is that we're really doubling down on the stuff that you have seen, the research report from the very first talk that we had today with Melissa, as well as the stuff that we're commenting on about how organizations are backing this now in a very, very serious way. So like I said, you've heard it here, in October in LA. And the next KubeCon, which will be in May of 2022 in Valencia, in Spain, where I live normally when I'm not visiting here in California. Very nice to be here, of course. It's going to be very interesting to see how much further we're going to be driving this, how much further down the field we're going to be running with the ball, and the different, like I said, waking people up to this idea. Over 500 organizations were interviewed, and so the results kind of speak for themselves in that sense. So we're going to be extending those points, taking deeper dives on some of the talks that we had today. We had a super great lineup of speakers. Obviously, for reasons of time, having so many talks, we had to cut some things a little bit short. But these are all things we could easily expand out into live streams, or as well as panels. So you can definitely expect more content based on the stuff that we covered today. Umair, is there anything else? You are hiring, and we want to make that very clear. They're hiring.
Absolutely. Come find me. I'm on Slack.
Easy to find.
Tweet friendly. At me. DM me. Whatever. Just look for Umair Mufti. You'll find me. Like I said, doesn't always have to be in agreement with any of the stuff that I said. If you want to come challenge any of my assumptions, I'm happy to hear your voice. So contact me.
All right. Perfect.